So, hi guys, my name is Igor de Souza. Thank you, Rafael, for the opportunity. Thank you for the introduction. So, I don't see my screen. I think you guys, no, here we go. So, I'm a current software engineer in a data engineer team. I have a lot of experience in software development and big data and a lot of time in the maker area. So, IGFA Souza, you can find me on all social networks. I think Rafael will put on the bottom as well. So yeah, today I want to talk about Raspberry Pi. I put the name from Java to data stream. So I will try to cover everything regarding Raspberry Pi, Java, and data stream process. So first, let's start with the basic. What is a Raspberry Pi? Raspberry Pi started in 2012. And when the Raspberry Pi released, they advertised themselves as the smallest computer around the world. Of course, this involves for the longest of the years. There is a lot of versions. So currently, the last version is the Raspberry Pi number 4, has 8 gigs of memory and things like that. And then we have the Raspberry Pi's different prices. So Raspberry Pi 0, it's around $5, and the Raspberry Pi 4 with 8 gigs is around $70. So you have a lot of boards in the middle. Raspberry Pi is a full computer, so needs a operational system. You have kind of a SD card that you install the operational system and where you run things. The Raspberry Pi Foundation provides the Raspberry OS, usually to be Raspberry. They rebranded the name 8 years ago, 1 year ago, and they already released the beta version for 64 bits. And of course, because it's a Linux open source, you can install Oracle Linux, CentOS, Ubuntu, and a lot of other options. There is Windows versions as well, and there is Android versions, so you can play with a lot of different technologies and things like that. The Pi OS, the official one, 64 bits and 32 bits, came with Java 11 already, so then you can use Java. And then that is the Raspberry Pi, the number 4. You have the options 2, 4, and 8 gigs. And you can see that there is, anyway, HMI, camera slots, processors, and things like that. USB comes with Bluetooth and internet, Wi-Fi, and things like that. And then on the top of the Raspberry Pi, you have the headers that we call GPIO, generic ports, generic platforms or ports, import and output data, input and output data. And then each ports do different things, and you can plug and play stuffs on the top. So you can put sensors, you can put LEDs, you can combine with IoT devices and things like that, and then do crazy stuff. And then the Raspberry Pi has the concept of hat. So hat is something that it fits perfectly on the GPIOs. So then you don't need soldering, you don't need to touch anything. And in this way, you have a plug and play another device. So you have hats for LEDs, you have hats for sensors and things like that. And for use the hats, for use the GPIO with Java, we have the Pi4j project. So Pi4j project is a lib that you can import in your project, and then you can control the pins of the GPIO in your Java program. So then you can use the energy, you can start sensors and things like that. And because you can put it's already with Java, but you can install any other different Java versions, you can use all the Java's projects around. You can combine with JavaFX, do some graphics, some interface. You can use JBang and do some scripts. You can combine with JRelease and any other jars that you can find. You can do web development, Spring, Quarks, Micronaut, Vertex, or Ellington, or whatever. You can even Microsoft gives a VS Code IDE, but you can find easy way tutorials how to install Eclipse or IntelliJ or any other options. Yeah, and of course you can use GraalVM. So put GraalVM, use it even with the other technologies. You can do R, Python, and JavaScript on the top of GraalVM or not. You can, on the 64-bit operational system, you can put GraalVM, you can generate native images, Micronaut, Quarkus, Spring, all them has the concept of native images already. You can use OpenJDK, you can combine with IoT, so you can install any MQTT broker or server. Of course, you can combine with Kubernetes as well, Dockers and Kubernetes. There is the Micro 8S, and the K3S, the catch-up version. It's a highlight version of Kubernetes specific for Raspberry Pi. There's thousands of possibilities. And of course, you can go for big data platforms. You can do for data stream platforms. That is what I want to focus here. So Apache Spark, Apache Flink, Apache Storm. You can even install Hadoop. You can do Hive. You can do Pig. You can do Hummer. You can do graphs. You can do crazy data structures, and you can do data Kafka as well, and RabbitMQ, and you can combine everything. You can do a cluster. You can combine several nodes and run everything. So I'm going to show a demo of things that I created, and I'm going to explain about the scenarios, and I'm going to try to give some possibilities or some ideas, that things that you can do. So the first one is this Java application here. That is a Duck, just with a servo motor. So then I move the arms of the Duck. And of course, you can, I think I can play again. And of course, as you can see here, the idea was a red and a green flag. And I was trying to create the alphabet with flags and things like that. Anyway, it's a really simple idea. You can find on my blog. I will find me on social network. All the things are there. So the second one here is a LCD. So this is a web application. It's based on Spring and Timeleaf framework. So just a simple web application. It's nothing fancy. It's just a bunch of HTML and CSS, a little bit of JavaScript that I created the thing. And I create a picture of the frame, and then this is generating my LCD. So just a small demo. So that one is a Quarkus using quite visual stuff. So then you can turn off and turn off the LCD. So this reflects on the real time. So you can turn off, and then this was in a real display as well. Another one here is kind of similar. That one is 4x7 segmented display. Here I'm doing the front end and Quark in React. So I have a combo box that I choose the specific region. I get the data from that region and I show. So it's small things. So this one is Micronaut with velocity. So you press on the screen, and then the head on Raspberry Pi follows the screen. So that one is using Javelin, and this is Rainbow Hat, so I can type 4 letters in an input text box, and then the 4 letters appears in my display. And I think the last one is Elidon. So that one I have the 14 segments display, and it's the same idea. So more than that, so here is, now that you see some ideas, you can create the components that you don't have. For example, a potentiometer. A potentiometer is that you can round and change the values. So if you don't have one, you can create a virtual one. So here I created in Vertex kind of web application that you have kind of a way to choose values between 0 and 100. And I use this value for control the luminosity of my LEDs, so increase and decrease. So you can do this with other components as well. Create a virtual one components when you don't have it. So this is using Vertex example. So, and then I have another one using cloud provider. Here is Oracle Cloud, but can be any cloud providers. So here I get data from the clouds, and I show in a fancy dashboard. So I have number of instances or number of things that I have in the cloud, VMs, network, and things like that, dashboard in real time. And anyway, you can create with different technologies. So those are the examples that make sense for me, but you can use this with any other technologies. You can use this with Kubernetes, you can use this with Java, you can use it with JVM, you can use it with GraalVM, you can JBank, you can mix everything together. But more than this, you use the Java and you use the Py4j for read the things and combine with the IoT stuff and sensors. And you can do data as well. And you can do data stream. So for data stream, we have Kafka, we have RabbitMQ. Of course, we have several other options outside. So this is the picture most popular and most common that people use to explain data stream. So you have the event stream at the top, a data structure that stays in memory that you can call whatever you want, a pipe, array, or things that you can append. So the events came, And then you append this on the event stream. You have kind of a list, a pipe array. And then you have the sequence, you have the date, and you have the sequence of the elements. And you can read and do the index. And of course, this index you can put in a data warehouse. You can do some kind of updates and save this, do some search, Elasticsearch or Solrs. You can do some ETL transformations, put this in a cache. And of course, you can have something that process the thing. And the output of one stream can be another stream. And you can have like a stream of a stream of stream of stream. So then, when I saw this, when I understood what data stream, and because I have a maker experience and I do a lot of things with hardware, I came with the ideas. Do I or can I use the concept of data stream and somehow combine this with IoT and try to explain this in a nice way? So the picture here I try to explain what is data stream. Is the green box on the middle that I have the records in a sequence way. Every new element is appended on the memory instruction, the data instruction, let's say. You have the producer and the consumer, the blue and the orange box. So the idea is the producer is writing new elements or new records in my data stream, and the consumer is reading. Of course, I can have this in parallel. I can have several producers. I can have several consumers. And majority of the technologies on data streams, the data stay there, so you can read several times, and you can always start from beginning again and again. So then I came with the idea. When I saw the data stream, I realized that, this looks like a LED stripe. So can I use a LED stripe to teach data stream funnily and nicely or easy way, or some kind of combining this with the Coded Dojo idea or of the STEAM idea to teach kids or teach teenagers programming and data stuff. It's really common. And there is a lot of projects, a lot of advertisements regarding machine learning on the edge, but not too much talking about data streaming on the edge. And again, this is the idea. So you can do data stream on the edge. And when I talk about the edge, I mean the Kafka, the broker, and the clients on the Raspberry Pi itself or on the board. So this is kind of an autorun of lights that I created a long time ago. So the idea here is every time you have a button, and every time that you push the button, the lights go further. So it's kind of a race, red against green. And then, of course, you can add a lot of things here. You can put this game more complex as ever. Best the one that completes 2 laps 1 and things like that. So I can add Kafka on the top of this. So how I can add Kafka on the top of this? Can I create a dashboard with the laps, with number of clicks per second or velocity or things like that? So then I can create things like that. So anyway, this is a fake-ish Grafana image, but you can have the velocity of number of clicks per second, things like that, and you can add more value for the game. And then when you talk about the Kafka, you have the 3 rows here in my table: number of messages, the size of the message per second, and the megabytes per second. And if you look the first and the last column, you're going to realize that there is not too much a relation. For example, so if I try to send 5 kbytes a message, I'm going to send 1,316 messages a second, and then after a specific time, I will be in average, or I will be sending 42 megabytes. And if you look at the last one, so if I increase the size of the message, so of course I send less messages per second. So 750 kbytes of message, I will only send 11 messages per second, and I end up with 8. But if you look on the middle, for example, 100 of kbyte of size, I have 98 megas per second, and then I end up sending more message. So then here there is a trade-off. First, there is no relation between the columns, and second, there is a trade-off. Do you want to send more? You want to send more messages per second, or you want to send less messages with a bigger value, or you want a better average megabytes per second of reading? So this is a trade-off. But on the top of that, I create a game, and actually I combine this game with the LED race. So the game is, I have a screen, 2 players. So the game is going to show one of the 3 columns as a target. So your target is send 750 message kbyte, or your target is to send 80 megas per second, or your target is to send 11 messages per second. So now that you have the target, you need to feel what you think is going to be the other one. And then when you feel the other one, the 2 players has a web application that shows for 30 seconds, is going to show. You need to send 8 megas per second. So then you need to fill the form for a value for messages and for a value for a number of the size. In 30 seconds, 2 players are going to fill, and then when you do submit, when the 30 seconds finish, what's going to happen is the LED race is going to start, but there is no one pushing the button for the let's go. It's just the calculation the Kafka do is going to fall. So then the result is something like that. So it's a race between blue and red and green, but then it's based on the form that it is. So it's a game based on the thing. And of course, you can combine this with any other ideas. So another idea is the cluster. So have several Raspberry Pi here, on 5 of them. And then you can put the Blink. Blink-T is a kind of a red that is the LEDs. And then you can use this for explaining things. Each one can be a node, each one can be a topic, each one can be a partition. You can use this for Kafka, you can use it for Docker, you can use it for Apache Spark, you can use it for Apache Flink, you can use it for Akka. Actually, there is thousands of similar ideas. If you Google, you're going to find people explain load balance, people explain a lot of things on the top of that. And the idea is like that. So here I have the master and some workers. And then I can, for example, every time that a new node joins the Kubernetes network, a light blink. The light is blue or green. If it fails, it's amber or red or things like that. Connection is amber, and when connected is green. If it fails, it's red. I can use this for explain the Kafka itself. So new elements, so another light. Imagine that I have 3 different sensors, temperature, humidity, and pressure. So which one has one color? So then I can explain things like that. I can do this. I can use this for simulations. So I can end up with showing some kind of this simulation. If you go on this Software Mill website, you're going to find the website who has the simulation. So this explains how Kafka works behind the scene. So there is 2 topics with replication. He reads an element and then goes for one, replication the others. So I can reproduce this video in that cluster of LEDs. Another crazy idea is the tic-tac-toe game. So here I have a web application that play the game. So I have showing 2 screens, screen A against screen B, and then I can have the data on the Raspberry Pi in real time. But more than that, everything go to a node, everything go to the broker, everything go to the Kafka. So the producer sends the data, and then I can reread that thing. So the sense that I can reproduce whatever player 1 is seeing on the player 2, and whatever player 2 is doing on player 1. And I can have the history of the game, and I can recreate the game. So once the game finishes, I have all the movements and all the sequence of events that happens, and I can re-show the game without anyone playing. And again, you can find similar ideas. I saw people doing this with Pac-Man. So the person play Pac-Man, and everything goes to Kafka, and then anytime the person can go there and read everything from Kafka again and replay the game based on the data that is on Kafka. And then you can see graphs like that. So on the top, I have the producers. The producer itself can be different Raspberry Pis. On the middle, I have the Kafka cluster. So I have the follows, the leaders, different nodes. Every box here can be a Raspberry Pi. And then on the bottom, I have the consumers, can be 1 or several. So I can have like 3 Raspberry Pi on the top, 3 Raspberry in the middle, 3 Raspberry Pi on the bottom. So I can have a cluster with producers, the cluster itself, and the consumers, everything on Raspberry Pi. So I can build Raspberry Pi everywhere. So that is the idea, that Raspberry Pi on the edge. So when I say Raspberry Pi on the edge, it's the client and the broker running on the Raspberry Pi, and can be several. So of course that I can copy this to a cloud, I can copy this for a specific machine, a local machine, things like that. The concept of cloud here can be, the concept of a broker here can be a lot of things. Can be a machine that I have in my laptop, for example, or can be a node on a cloud provider and things like that. The idea is I have the Raspberry Pi that has the Kafka broker there. So once the data there, I can replicate this anywhere, or I can just consume it from there. Where the data came from can be anywhere, but in the case, I can have the consumer in a Raspberry Pi as well. So read data sensors, read data from the Raspberry Pi, read data from the LED display, the LED stripe from the weather, from any website and things like that. So consumer, producer, and broker, everything run Raspberry Pi. So another example that I have here, I have two Raspberry Pis. So the left one has the sensor head. It has humidity, pressure, and temperature sensors. And on the right one, I have the JFX LCD display. And they have some buttons on the bottom of the left side. So when I press one button, I show pressure value. The second button show temperature value, and the third one show the humidity value. So all the values came from the sensor on the sensor head on the left side, and they are sent to the Kafka. I have a two-node Kafka broker here, so I have two nodes, and all the data is on real time. Another thing is the A-Ink display. So on the top is the, because I'm in Ireland, in Dublin, so on the bottom one is the Dublin bus information on real time. And on the bottom one is a A-Ink display. It's quite small. And I get the data from the open public API from the government that shows the real time of the data from the bus. And I can display on the ink display on real time. So I get the data, put on Kafka, and then I can read several times and do summarize. This other example here is using a smart bulb and a smart plug. So I create a Spring application that do the switch button. Anyway, I got the CXS and the things on the internet. So when I press the button, I turn on, turn off the data, the bulb and the smart plug and the smart bulb. And then, of course, I have the energy consumption from both in real time on my Kafka, so I can analyze, do some history and things like that. And nowadays, smart devices that are everything in your home. So even my wash machine connects with internet, my heater and things like that. So I can get the data in real time. So I have smart data everywhere that I can get. Use a Raspberry Pi for collect the data. Put this in a Kafka, so then I have a history and I can do some analysis. I can have graphs and things like that. Another famous concept is the connected vehicles. So Rafael was talking about that I show some cars, so I will try to show something here as well. So connected vehicles, every car has a bunch of sensors. So if you get a Formula One car nowadays, they have thousands of sensors, even from tire, for fuel, for everything on the car. So then you have information about the car, who is around you, and you can anyway use this for control the car and maybe pilots automatic way, autonomous car and things like that. So there is a game from Anki, it's called Overdrive. There is Anki Overdrive, there is the Fast and Furious version as well. So it's kind of a toy that is Autorama-ish way. So you have 2 or 3 cars and you control by your mobile or a tablet. You connect the car in the Bluetooth way in your car. And then it's a race. You need more laps in a specific time, and then that's it. And if you go faster, the car goes outside of the circles and things like that. The cars can hit one each other and things like that. But because it's based on Bluetooth, you can use the Raspberry Pi, forget the data from the Bluetooth, translate this and put it in a Kafka copy. So then that is exactly what I did here. So here I'm showing my terminal, so I get the position of the car, velocity, which piece his are, and things like that, space regarding the car. And then you can see the car is just walking slowly in my circuit. So on the things I have the offset. So the offset -68 to +68 is how left or right on the circuit the car is. Then I have the lanes, so 4 to 1. So then I can somehow change the lanes, 1, 4, 2. And then I have for each part of the circuits, I have the track position. So the first one is 0, 1, 2, 10, 11, 12. So then I know the car is in the start of the track, on the middle, or on the end. So once the car goes and gives one lap, I put everything on Kafka, so then I can analyze that thing. So what I can do with that information is, so basically, I can build the map of the circuits. So here is 2 different circuits that I create the map. And then the number is, each track has a specific ID. So the ID can be generic, can be handle, can be in a sequence or whatever. And then you have the specific track, you have the ID of the track, and you know that is a right turn, that is a left turn, or there is a flat, or there is a cross, or things like that. So if you get the second one on the right, you can try to analyze, and you can try to teach the car to go and give the fast lap. So you can do things like that, small things. So when he is on the track ID, I don't know, X, that is the flat out, it should speed up. When it's close to the last one that is turning right, start to brake. And then you can analyze this and try to teach the car. He needs to go and create the best lap. So then you can create another game and you can say, I challenge people to play with the mobile or the tablet and beat my car that is going to read the Kafka data and is going to be the best lap on the circuit. You can use techniques for turning. So this is a technique that the pilots use in Formula 1, for example. The green line, the green things that the car follows, so they try to flat the turn. So then they don't need to slow down too much because they flat the turn, so they don't need to lose too much energy for do the turn. So you can do this moving the car left and right. So I know if I know that I need to turn right, I need to put my car as left as possible, because then I open and flat the turn, and then the car can speed up more things. The other thing that we can do is the Anki sell patches that you can add more circuits and increase the things like that. So they have that one that is the cross. So with the cross, I can do some cruisements, and then this is dangerous because the car is can hit each other. I have another thing that is the heads for lights. So unfortunately, the car doesn't have a camera and sensor, so I cannot detect the lights and stop and things like that. But I can analyze the circuit, and I can understand that there is a cruisement in front of me. So here, there is the example that the car knows that the other is going to pass, so he stop and don't hit each other. So the idea that is, you analyze the thing, you have the history of the data, you have the data in real time that is on Kafka, and you can understand, so you stop and you don't hit it there. So that was the idea. I try to explain that combination of Kafka, Raspberry Pi, and Java are the things that those things that you should use. And so think on the Raspberry Pi as a kind of a really nice place to start. So first, it's cheaper. You have versions from $5 to $7. You can, by default, you have Java by the official operational system. You can, because it's Linux based, you can install any Linux version, Ubuntu, CentOS, Oracle Linux, and so on. You have Android versions, so you can even play with Android, Kotlin, things like that. You can put OpenJDK. You can play with GraalVM, so you can go for JavaScript, Python, R. You can play with Kotlin, any JVM basic language, Kotlin, Scala, Groovy, and things like that. Comes with Java 11, but you more than open. And if you look on my blog, there is already Java 17, a beta version you can install. If you get the most expensive version or the most powerful version, the Raspberry Pi 4 with 8 gigs, you can run Kafka. Even in the version 3, you can run Kafka. You can create a broker. You can have a cluster of Kafka. So then you can send data, consume data, analyze data, do real-time dashboards, and do things like that. You can play with other things in Java, JBang, JRelease, JavaFX. You can play with web, Micronauts, Kubernetes, Spring, Elidon, Vertex X. if you have the GraalVM, you can do native image on real time. You can play with Kubernetes. You can play with data stream. So you can have a RabbitMQ, you can have Kafka, you can have data stuff, Apache Spark, Apache Flink, Apache Storm, Hive, Pig, Hummer. You can put everything. You can even put everything together. You can do Elasticsearch, Solaris, Neo4j, MongoDB, Cassandra, and really crazy stuff. You can create a cluster of Cassandra, you can create a cluster of Scylla, you can create a cluster of Akka, you can create a cluster of Kubernetes, you can create a cluster of Spark, you can create a cluster of Raspberry Hadoop, a cluster of Kafka, and so on. You can play with Java and all the JVM technologies. You can play with R, Java, Python, any other things. You can even install IDEs, VS Code, IntelliJ, Eclipse, and so on and so on. Small hardware that you can use the GPIOs for do electronic stuff, sensors, LEDs, LED stripe, combine data everywhere. You can even try to analyze the data on the edge as well. So that is really main topic, machine learning on the edge. The Raspberry Pi doesn't have too much GPU technology, so you can do some analyze, but not too much. But you can put this on Kafka or on a cloud. You can run the Kafka local as well, can do a lot of things, combine everything. So a really nice tool, let's say, for start playing with technologies. You can explore tests as well. You can do things like I did. I have LCD, so I'm going to create a web application that I draw and goes there. I have a 7x7 LED matrix. I will create a web application that I click and I need a potentiometer, but I don't have it one. All right, I will create a web application that simulates a potentiometer. So then I can use that thing for my real stuff. For example, the Duke one with the hands. I can use my web application for control the arm of the Duke. And things like that. So combining this with crazy ideas, combining this with the Coder Dojo idea. If you don't know what is Coder Dojo, coderdojo.com or .org. Organization for teaching STEAM for kids and teenagers, anyone in theory. And then you can teach them programming, you can teach them nice stuff with hardware, you can teach them data structure, data streaming, and data streaming on the edge, plus machine learning on the edge as well. Combination of everything. So the talk here was the idea to show from Java to data stream. So you follow up, you go step by step, have the border, you have Java already, you can install any flavor or fashion of Java, create a web application, put maybe some data, you can combine with IoT, MQTT, you can use the Bluetooth, you can use the Wi-Fi, any other crazy protocol that you want, maybe install Kafka, put the data there, try to replicate strings, producer, consumer, and things like that. And so I hope I gave a superficial vision of a lot of things. I know there is a lot of content here. I try to show some nice demos that I created, LCD, graphs, matrix, sensors, the LED stripe, the Anki card, and things like that. So that's it. So thank you again, Rafael. My name is Igor Souza. Currently, I'm software engineer in a data engineer team. So IGFA Souza, you can find me everywhere. So everything that I said here, or everything that I show, all the demos, code, everything you can find on my blog. So igfasouza.com/blog, you can find everything. If for some reason you find out that is not there, maybe will be. So deal with me, a little bit of patience, will be there. So I hope you like it. And thank you, guys. So I'm happy to answer questions.